Okay, this is a velocity time graph. Part A asks, when is the object at rest? So if this is a VT graph, then you have to cross 0 meters per second to be at rest. So that would be here, here, and there. So it's at rest at 0 seconds. I guess that's 7.5 seconds. And you have to make an estimate that I'm going to call it 18.8 seconds. The next part says, when's the object moving with a constant velocity? So on a VT graph, a constant velocity is a horizontal line right there. So that's constant velocity, and that's between 13 and 16 seconds. So 13 and 16 seconds. In fact, your constant velocity would read directly what this says, which is minus 60 meters per second. At what interval represents constant acceleration in the negative direction? So we don't need to figure the value out, we just got to find out where it's negative. And that's down and to the right, which is this way, which is going to be from 4 seconds to 13 seconds. And now we get to the calculations. Determine the average acceleration. Remember, your formula for acceleration, or average acceleration, is v2 minus v1 over t2 minus t1. Same formula as before, just different letters. So average acceleration between 16 and 20 seconds. Going to be from here to there. So that's going to be v2, which is 30, minus v1, which is minus 60. t2 is 20 minus 16. So you're going to end up with, let's see here, minus positive 90 over 4. Right? So let's pull out the old calculator. 90 divided by 4. So that's going to be positive 22.5 meters per second. Next one is 4 to 16. That's a little bit different. You're going to want to find the average acceleration for that line between there and there. So you got to create your own line. It's still v2 minus v1. v2 is minus 60. v1 is 40. t2 is 16. t1 is 4. So you're going to end up with minus 100 over 12. So you're going to end up with an average acceleration of minus 8.3 meters per second squared. Oops, I screwed that up there. That should be meters per second squared down there. Meters per second squared, because this is acceleration. Okay, so there's for I, there's for double I, and now we got to find from 0 to 20, which is going to be from here to there. Let's see if I have a color. That's going to be this line between there and there. So that's going to end up being v2 minus v1. So v2 is 30 minus v1, which is 0. t2 is 20 minus t1, which is 0. So you're going to end up with positive 1.5 meters per second squared. So there are your 3 average accelerations. Next, we got to find total displacement of the object and then calculate the average velocity. That's a tricky one right here, average velocity. Total displacement is not that big of a deal. I'm going to get a bigger graph and we're going to find total displacement. To find total displacement on a VT graph, you need to find areas. So you're going to break this thing down into areas. I'm going to call that area 1, I'm going to call that area 2, I'm going to call that area 3, 4, 5, 6. I'm going to find all those areas. And then to find your total displacement, you add them up. Keeping in mind that all of the ones on this side are positive and all the ones on here are negative. And so you're going to just keep that positive, keep those negatives, find your total displacement. So let's see here. For area 1, it's a triangle. So it's 1/2 of your base, 4, times your height, 40, which is going to be 40 times 2, so that's going to be 80, positive 80 meters. Area 2 is also a triangle, 1/2 of your base. Now this is that one that's kind of halfway through. I called it 7.5, so I'm going to go 1, 2, 3. So that's base is 3.5, height still 40. So area 2 ends up being positive 70 meters. Area 3 down here is another triangle, 1/2 of your base, 1, 2, 3, 4, 5.5, and my height minus 60. So area 3 ends up being minus 165 meters. Area 4, rectangle, so that's just base times height, so that's 1, 2, 3 times 60. So that's minus 180. And let's see, area 5, right there, half base times height, 1, 2, what I call that? I called it 18.8, right? So that's going to be 12.8 times minus 60. So that's going to be 2.8. So that's going to be minus 84. And finally a 6. A little guy at the top here, that's going to be 1.2 is the base. The height is 30. So that's going to end up being 1.2 times 30 divided by 2. So that's going to be 18. Positive 18 meters. Whew. Okay, total displacement. Add them up, keeping the direction in mind. Minus 165, minus 180, minus 84, plus 18. Your total displacement then, let's figure this out. It's 80 plus 70 minus 165 minus 180 minus 84 plus 18. Now if I did that all right, you get minus 261 meters is your total displacement, and that is the answer for E. F asks us for the average velocity. Now this is the one that I said was kind of tricky, and tricky in the sense that we're going to need to use the total displacement. I'm going to go up here for it because I have the space. Average velocity is total displacement over total time. If you do that on a VT graph, you can find your average velocity. So for us, that's going to be 261 or minus 261 divided by your time, which is totaled, which is 20. So your average velocity then, 261 divided by 20, that's minus 13.05 meters per second. And you can see that your velocities are mostly in the negative direction here. So that ends up being about what you would think it should be. So remember, on a VT graph, displacement is areas. If it's a triangle, it's the area of a triangle. If it's rectangle, it's area of a rectangle. Aboves are positive, belows are negatives. Okay? There you go.